Okay, so now I'm going to show you how we use the information that I just taught you about parallel lines and the angles that are created with the transversal. And so let's take a look at the first example here. So we have, in this example, I can see in the diagram that the two lines are marked parallel. So when they're marked parallel, then all of those things are true that we learned about previously. And that is that corresponding angles, alternate interior angles and alternate exterior angles are congruent, and same side interior and same side exterior angles are supplementary. So I guess what I first need to do in this diagram is decide what kinds of angles do I have here. So I can see that I have my transversal. We'll mark that in red. And I can see that I have the two lines that are parallel. So I'm noticing that 112 is in the exterior, and the angle with the question mark is also in the exterior, and those angles are on opposite sides of the transversal. So those are alternate exterior angles. So we know that when the lines are parallel, which they are, then alternate exterior angles are congruent, which means I can go ahead and mark 112 degrees in the angle that's marked with a question mark. Taking a look at the next example, again, I see parallel lines. They're marked with those red arrows, and I see my transversal. So I'm trying to figure out what kinds of angles we have here, and the two angles that we have numbers and variables in are on the same side of the transversal, and they're on the inside or interior of the parallel lines. So we have same side interior angles. So we know when lines are parallel, same side interior angles are supplementary. So supplementary means that I'm going to take the measures of both of these angles and add them together, and that sum should be 180 degrees. So I have 84 plus x, which I'm adding to x plus 104. And that sum should be 180 degrees. So I'm going to combine like terms. I have two x's. I have 84 plus 104, which gives me 188. And the sum is 180 degrees. So I'm going to go ahead and solve for x. So when I subtract 188 from both sides, I get 2x is equal to negative 8 degrees. And then I'm going to divide both sides by 2, giving me x equals negative 4 degrees. Now, in this particular problem, they asked me to solve for x, so I have done that. I did solve for x. They're not asking for a particular angle measure, they're just asking me to solve for x. So x equals negative 4 degrees, which sounds kind of strange that it's a negative number. However, if I were to substitute negative 4 back into one of those angles, I would see that the measure of the angle is a positive number. It's just that x itself is equal to negative 4 degrees. Let's look at the third example. So find the measure of the angle indicated. So we're looking for this angle here. So before I can find the measure of that angle, I'm going to first have to figure out what x equals, just like we did in the last example. So I'm identifying my transversal, and I'm identifying my parallel lines. And I'm seeing that these two angles that have something marked in them, they are on the opposite sides of the transversal, and they're on the interior of the parallel lines. So they're alternate interior angles. We know that when lines are parallel, alternate interior angles are congruent. So I'm going to set the measure of the first angle, 21x plus 6, equal to the measure of the second angle, 22x plus 2, and I'll solve for x. So if I subtract 21x from both sides, I'm getting that 6 is equal to x plus 2. And really, these are degrees we're talking about here. So I'm going to subtract 2 from both sides, and I'm getting that x equals 4 degrees. Okay. Now, I'm not done though this time. This isn't like the last problem where we were asked to solve for x. Here, I'm asked to find the measure of the angle indicated, the one marked with an arrow. So what that means is I have to substitute x equals 4 back in to 21x plus 6 for x, and I'll figure out what the measure of that angle is. So 21 times x is 4 degrees plus 6 will give us the angle we're looking for. So we have 21 times 4 is 84 plus 6. And when I add 84 plus 6, I get 90 degrees. So the measure of this angle here that's indicated with the arrow, the measure of that angle is 90 degrees. So I'll just go ahead and mark that. Okay, now let's take a look at what are called conditional statements. A conditional statement is often written in if-then form. So if some condition, then some other condition. So here's an example of an if-then statement. So if you love all fruits, then you love bananas. So the first event is you loving all fruits. That's the P. And then if so, then you love bananas. That's the Q. So if P, if you love all fruits, then Q, then you love bananas. So that would be true. If I love all fruits, then I love bananas because bananas are a fruit. So that's a true statement. That conditional is a true statement. We can also sometimes look at what's called the converse of an if-then statement. The converse, notice what happens, it flips. So what was the second event, the Q, is now the first event. And what was the first event is now the second event. So if I take the example that we started with, if you love all fruits, then you love bananas, and I find the converse of that statement, the converse would be, if you love bananas, then you love all fruits. Okay, so that's how we write the converse. Now, sometimes in geometry, we'll have conditional statements that are true, but then when we look at the converse is not true. And other times in geometry, both the conditional statement and the converse will be true. In this particular example, just because I love bananas doesn't mean that I love all fruits. So here we had a true conditional statement, but its converse is false. It's not necessarily true. Now, how does that relate to what we're talking about, to parallel lines? Well, with parallel lines, we already know, we have some theorems here. And by the way, a theorem is something that can be proven to be true, which later in this semester we'll look at writing some proofs for those theorems. But for now, we'll accept them as true. And these are the theorems that we actually already know. So if we have two parallel lines and they're cut by a transversal, we already know that corresponding angles are congruent. We also already know that if two parallel lines are cut by a transversal, then alternate interior and alternate exterior angles are congruent. And the last thing we know is if we have two parallel lines that are cut by a transversal, then same side interior or exterior angles are supplementary. So all that we know to be true. So those are our if-then statements. Those are our conditional statements that we already know are true, or we could prove that are true. In this case, the converse of each one of those statements is actually also a theorem, which means it is also true or can be proven to be true. So now, if I flip them around and I write the converse, now we're not starting with the lines being parallel like we were here. We're starting with the specific types of angles being congruent or supplementary. And if they are congruent or supplementary, depending on what we're talking about, then we can say that the lines are parallel. So in this case, the original theorems are of course true, but the converse of each one of those theorems is also true. So if two lines are cut by a transversal such that we have corresponding angles being congruent, or alternate interior angles being congruent, or alternate exterior angles being congruent, then we can say that those lines are parallel. also if we have two lines that are cut by a transversal, so that we have same side interior angles or same side exterior angles being supplementary. If we have those angles being supplementary, then we can say that the lines are parallel. So let's take a look at some examples and how we would use that. Example 1. So it says find the measure of the angle that's marked with a question mark that makes lines U and V parallel. So if you notice in this diagram, we don't have U and V marked with the parallel markings. We don't know that they are parallel. But we're going to say what this angle would have to measure in order for us to say that the lines are parallel. So I'm going to first look at the two angles, the one that's marked 85 degrees and the question mark, and I'm going to decide how those two angles are related to one another. If the lines were parallel, then how are those angles related to one another? So again, I'm looking at the transversal and the two lines, and I'm seeing that the angle here at 85 and the angle with the question mark, they're both in the same spot, or they're corresponding angles. So corresponding angles are congruent when the lines are parallel, which means that when the corresponding angles are congruent, we can say that the lines are parallel. So in order for us to say that these two lines, U and V, are parallel, we would have to say that the question mark would have to measure 85 degrees because corresponding angles are congruent. Using that same idea here for the second example, I'm noticing my transversal and my parallel lines, which again, they're not marked parallel, but we're going to hopefully prove that they are. So if they were parallel, I'm looking at the 79 degrees angle and the 11x minus 9, and I'm seeing how they're related to the lines. So I can see they're both on the inside or interior of those lines, and they're on the same side of the transversal. So we know that in order for the lines to be parallel, those same side interior angles would have to be supplementary. So meaning we need to put 11x minus 9 added to 79 degrees, and that should equal 180 degrees because same side interior angles are supplementary. And if that's true, then the lines are parallel. So combining like terms, I have 11x, 79 minus 9 gives me 70 equals 180 degrees. So subtracting 70, I'm getting 11x equals 110 degrees. And then dividing both sides by 11, I'm getting x equals 10 degrees. Now I want to make sure I answered the question. So it says find the value of x, and I did do that. X would have to be 10 degrees. And if x is 10 degrees, then both of these angles are supplementary. And if they're supplementary, because they are same side interior angles, we could say that the two lines are parallel.